Right now, in tropical plantations across the world, something incredible is happening. Workers are scaling 60-foot trees to harvest fruits that will soon become the golden oil hiding in half the products you use every day. We're talking about a process so efficient and fascinating that it turns millions of spiky orange fruits into liquid gold using techniques that seem almost magical. But here's what most people don't realize. This isn't just agriculture. This is one of the most sophisticated food transformation processes on Earth, where every single step has been perfected over decades to squeeze every drop of valuable oil from fruits that most people have never even seen. In today's Lord Gizmo episode, we're going inside this incredible world where nature meets engineering, where millions of palm fruits get transformed into the most versatile oil humans have ever discovered. And trust me, once you see how this actually works, you'll never look at cooking oil the same way again. Picture walking through a plantation where every tree around you is a living oil factory. These aren't ordinary fruit trees. Each oil palm can produce up to 1,620 kilograms of fruit every single year. That's roughly 3,570 pounds from one tree. To put that in perspective, that's like having a tree that produces the weight of a small car in fruit annually. But here's what makes these fruits absolutely unique. They're basically nature's most concentrated oil storage system. Each individual fruit, about the size of a large grape, contains up to 70% oil in its flesh. Imagine if every grape in a bunch was actually a tiny oil container, and you start to understand why palm oil has revolutionized global food production. The trees themselves are engineering marvels. They start producing fruit at just 3 years old and keep going strong for 25 years. Every single week throughout the year, they're dropping fresh bunches that weigh between 20 to 50 pounds each. A single mature tree can carry 12 to 15 of these massive bunches at any given time, each containing 1,500 to 2,000 individual fruits. What's mind-blowing is how these trees signal when they're ready for harvest. The bunches gradually change from dark purple to bright orange, and individual fruits start naturally dropping to the ground. It's like the tree is sending a message, "I'm ready, come get me." Experienced harvesters can read these signals from incredible distances. Harvesting palm fruits requires skills that take years to master, and timing that can make or break the entire operation. Walk onto a plantation during harvest time, and you'll see workers moving with precision that would impress any athlete. They're not just picking fruit, they're performing a carefully choreographed dance with trees that tower above them. For shorter trees, harvesters use a tool that looks like it came from medieval times, a curved sickle designed specifically for cutting fruit bunches. The blade has to be sharp enough to cut through tough stems in one clean motion, but controlled enough not to damage the tree or surrounding bunches. But the real skill shows when they tackle the tall trees. Using poles that extend up to 20 feet with that same curved blade attached, these workers can precisely cut heavy bunches from distances that seem impossible. The physical coordination required is incredible. They're essentially performing surgery on a target 60 feet above their heads while standing on uneven ground. Here's something that'll blow your mind about the timing. Harvesters know exactly when a bunch is perfect by counting fallen fruits on the ground. 1 to 12 naturally dropped fruits signals optimal ripeness. 0 fruits means it's too early. More than 12 means they've waited too long and oil quality is already declining. The precision doesn't stop there. Each bunch has to be cut at exactly the right angle to avoid damaging the growing point where next month's bunch is already forming. Cut wrong, and you've just cost the tree several months of production. These workers are making split-second decisions that affect the tree's productivity for months ahead. Once those bunches hit the ground, an invisible countdown timer starts ticking. This isn't like harvesting wheat or corn that can sit around for weeks. Palm fruits have a very specific enemy, enzymes that start breaking down oil quality the moment fruit separates from the tree. Every hour that passes without processing means lower quality oil and less money for everyone involved. That's why harvest crews work with urgency that's almost military-like. Bunches get loaded onto trucks or carts within minutes of being cut. Workers use hooks and specialized tools to handle these heavy, spiky bunches without injury. The logistics are absolutely incredible. Trucks are constantly moving between plantation sections and mills, creating an endless convoy of fresh fruit that never stops flowing. Radio communication keeps everyone coordinated. Harvesters report which sections are ready. Truck drivers call in their arrival times, and mill operators adjust their processing schedule accordingly. But here's the fascinating part about these bunches. They're not just random collections of fruit stuck together. Each bunch grows in a specific pattern around a central stalk, with fruits embedded in spikelets that branch off like a complex tree structure. Nature designed the most efficient packaging system possible, protecting individual fruits while making the whole bundle easy to transport. When those trucks roll up to palm oil mills, what happens next looks like something from a futuristic food factory. These facilities are designed to handle massive volumes. We're talking about processing 60 to 100 tons of fresh fruit bunches every single hour. That means about 2,000 to 3,000 individual bunches flowing through the system continuously. The first thing that strikes you about these mills is the scale. Conveyor systems stretch for hundreds of feet, carrying an endless stream of orange bunches toward massive processing equipment. Steam rises from multiple points throughout the facility, and the air fills with the sweet, earthy smell of fresh palm fruit. Workers wearing protective gear guide the bunches through quality checks, removing any that show signs of damage or over-ripeness. It's like an inspection line where every bunch gets evaluated in seconds before moving to the next stage. The speed and accuracy required is remarkable. They're making quality decisions about products worth thousands of dollars while keeping pace with a system that never stops. Storage areas hold thousands of bunches in carefully organized sections based on harvest time and quality grade. The newest arrivals get priority processing, while slightly older bunches wait their turn. Even this storage is engineered. Ventilation systems keep air moving to prevent heating, and drainage ensures no moisture builds up. What happens next is where science meets industrial art. Those fruit bunches get loaded into sterilization chambers that look like massive pressure cookers capable of holding hundreds of bunches at once. These aren't gentle processes. We're talking about industrial-scale steam treatment that transforms the fruit at a molecular level. The chambers fill with steam at temperatures reaching 275 to 285 degrees Fahrenheit under pressure that would make your ears pop. But this isn't just about killing bacteria. The steam performs multiple chemical reactions simultaneously. It breaks down the bonds holding fruits to bunches, softens fruit flesh, stops enzyme activity, and begins the process of releasing oil from plant cells. The timing has to be absolutely perfect. Most operations run sterilization cycles for 60 to 90 minutes, but some push it to 120 minutes depending on fruit variety and desired oil characteristics. Too little steaming, and fruits won't separate properly. Too much, and you start damaging the oil itself, reducing both quality and quantity. During sterilization, you can actually hear the process working. Steam hisses as it penetrates the bunches. Pressure relief valves release excess steam in rhythmic bursts, and the bunches themselves make subtle crackling sounds as internal structures break down. It's like listening to chemistry in action. When the chambers open after sterilization, what emerges looks completely different from what went in. The bunches have changed color from bright orange to a deeper, richer hue. The fruits are noticeably softer, and many have already started separating from the central stalk. The transformation has begun. Next comes one of the most satisfying parts of the entire process: threshing. Picture a rotating drum the size of a small room, with metal bars running lengthwise along the inside. Sterilized bunches tumble inside this drum while it rotates, and the motion causes every single fruit to fall away from the central stalk. The sound is incredible. Thousands of fruits dropping and bouncing around while empty stalks gradually separate out. It's like nature's most productive percussion section, with each fruit adding to a rhythm that continues as long as the drum keeps turning. Workers can actually tell how well the process is working just by listening to the sounds coming from the thresher. What emerges from this separation tells a fascinating story about efficiency. The empty bunches, now stripped of all their valuable fruit, don't become waste. These fibrous stalks get sent to boilers where they burn as fuel to generate steam and electricity for the entire mill operation. It's brilliant engineering. The waste from processing becomes the energy that powers the processing. The separated fruits move along conveyor systems toward the next stage, but even here, quality control continues. Workers remove any remaining stalk pieces, damaged fruits, or foreign objects that might have made it through previous stages. Every fruit that continues the journey represents potential oil, so nothing gets overlooked. But here's something remarkable about this separation process. It's almost 100% efficient. Advanced threshing systems can separate over 99% of fruits from bunches, leaving virtually nothing valuable behind. The mechanical precision required to achieve this while handling thousands of bunches per hour is absolutely incredible. The separated fruits now enter what's called a digester, and this is where things get really interesting. Picture a heated cylindrical tank with a central rotating shaft that has thick metal arms extending outward. These arms rotate slowly but powerfully, mashing the fruits while steam maintains perfect temperature conditions. This process looks violent, but it's actually incredibly precise. The rotating arms break down fruit flesh just enough to rupture the oil-containing cells without destroying them completely. Too much mashing, and you damage the oil. Too little, and you don't release enough oil from the fruit. Finding that perfect balance is what separates good mills from great ones. The digester operates at temperatures between 194 to 203 degrees Fahrenheit, and the entire process takes about 15 minutes per batch. During this time, you can watch the fruits transform from recognizable palm fruits into what looks like thick orange porridge. But embedded in that mash are millions of oil-rich cells just waiting to release their liquid treasure. Steam injection during digesting serves multiple purposes. It keeps everything at optimal temperature for oil release, adds moisture that helps separate oil from fruit fibers, and creates the right consistency for the pressing stage that comes next. The steam also carries away volatile compounds that could affect oil flavor and aroma. What's fascinating is how the digester arms move. They're not just spinning randomly. The rotation speed, arm design, and movement pattern have all been engineered to create optimal shearing forces that release maximum oil while preserving oil quality. It's mechanical engineering applied to biochemistry. Now comes the moment where everything changes. The pressing stage where mashed fruit becomes liquid gold. Modern mills use twin-screw presses that are basically two massive screws rotating in opposite directions, creating incredible pressure that squeezes oil right out of the mashed fruit. But here's where the technology gets really smart. The pressure isn't just randomly applied, it's automatically controlled by monitoring electrical current draw from the motors. When the motors work harder, the system knows pressure is increasing. Too much pressure breaks the kernels inside fruits, contaminating the oil. Too little pressure leaves valuable oil in the waste. The system finds that perfect sweet spot where maximum oil extraction occurs with minimum contamination. We're talking about pressure levels that can reach several hundred pounds per square inch, applied with precision that varies based on real-time feedback from the pressing operation. What emerges from these presses is a revelation. On one side, you get a mixture of crude palm oil, water, fruit particles, and various debris. It's cloudy, thick, and doesn't look much like the cooking oil you'd recognize. But hidden in that mixture is the valuable crude palm oil that will eventually become the clear, golden product the world depends on. On the other side comes press cake, a mixture of palm fibers and nuts that still has its own valuable components. This isn't waste either. The nuts get cracked open to extract palm kernel oil, a completely different product with unique properties. The fibers become fuel for the mill's energy systems. It's like getting 3 different valuable products from pressing one batch of mashed fruit. Taking that messy mixture from the presses and turning it into recognizable oil requires some serious engineering magic. The crude oil mixture gets pumped into clarification tanks, where physics does most of the heavy lifting. Since oil is lighter than water, it naturally wants to float to the top when given the right conditions. But it's not just about waiting for gravity to work. The mixture gets diluted with hot water heated to exactly 185 to 194 degrees Fahrenheit. This reduces the oil's thickness and helps everything separate more cleanly. Vibrating screens remove bigger particles first, creating a cleaner mixture for the settling tanks. The settling process is where patience meets precision. Over 1 to 3 hours, different components separate into distinct layers based on their density. Oil floats to the top, water settles in the middle, and heavier particles sink to the bottom. But even this apparently simple process requires constant monitoring and adjustment. What's remarkable is how mills have learned to recover every possible drop of valuable oil. Even the sludge that settles at the bottom contains oil that can be recovered. Centrifuges spin this sludge at incredible speeds, using centrifugal force to separate any remaining oil from solid particles. Nothing gets wasted when you're dealing with a product worth over $1,000 per ton. The result of all this separation is crude palm oil, a deep reddish-orange liquid with an earthy, slightly sweet smell that's completely distinctive. It's recognizable as oil now, but it's still far from the refined product that ends up in consumer goods. This crude oil contains natural pigments, has a strong flavor, and would give most foods an unpleasant color and taste. Here's where crude palm oil undergoes its most dramatic transformation. Refineries take that reddish, aromatic crude oil and turn it into the clear, odorless, stable product that modern food production depends on. This process involves chemistry that would fascinate any science enthusiast. First comes degumming, where phosphoric acid gets carefully mixed with the oil to remove gums, trace minerals, and unwanted fatty acids. It's like giving the oil a precise chemical treatment that pulls out all the components that could affect stability or flavor. The acid binds to impurities, making them heavy enough to separate out through centrifugal force. The chemistry here is fascinating. Phosphoric acid doesn't just randomly grab onto impurities, it forms specific chemical bonds with phospholipids and metal ions that would otherwise cause the oil to degrade over time. It's molecular-level precision applied to industrial-scale production. Then comes bleaching. But this isn't the household bleach you're thinking of. This process uses special clay called bentonite calcium in vacuum chambers. The clay acts like millions of microscopic magnets, attracting and holding onto color pigments and remaining impurities through a process called adsorption. The bleaching process is so effective that oil goes from deep orange to light yellow in a single step. But it's not just about color. This step also removes compounds that could cause the oil to go rancid, extending shelf life dramatically. The clay literally pulls unwanted molecules out of the oil while leaving the valuable oil components untouched. The last step in creating refined palm oil is deodorization, which is essentially steam distillation taken to an extreme level. The oil gets heated to temperatures between 464 to 500 degrees Fahrenheit under vacuum conditions, while steam carries away any remaining odor compounds. This process is like giving the oil the ultimate purification treatment. Under these extreme conditions, volatile compounds that cause flavors and odors turn into vapor and get carried away by the steam. What remains is oil that's completely neutral in taste and smell, a blank canvas that won't interfere with whatever food it's added to. The engineering required for deodorization is incredible. Maintaining those high temperatures under vacuum while continuously injecting steam requires precise control systems that monitor and adjust conditions multiple times per second. The slightest variation could affect oil quality or create safety hazards. When the deodorization process finishes, what emerges is transformed beyond recognition. The deep orange aromatic crude oil has become crystal clear, completely odorless, and perfectly stable. It's the same basic oil that started in those palm fruits, but now it's been purified to a level that makes it suitable for everything from cooking to cosmetics. Let's talk numbers, because the scale of this transformation is genuinely mind-blowing. A single modern mill can process millions of individual palm fruits every single day. We're talking about facilities that transform roughly 2,000 tons of fresh fruit into 400 tons of crude oil daily, working 24 hours a day, 365 days a year. Indonesia alone processes enough palm fruits annually to fill about 15,000 Olympic-sized swimming pools with crude oil. Malaysia adds significantly more to global production. Together, these countries are transforming billions of palm fruits into the oil that keeps global food production running smoothly. The efficiency achieved in modern mills is remarkable. Advanced facilities can extract over 95% of available oil from processed fruits. The remaining 5% mostly stays trapped in fiber structures that would require more energy to extract than the oil is worth. But even this waste becomes valuable as fuel for mill operations. The journey from palm fruit to the products in your kitchen involves multiple transformations, each adding value and functionality. That refined palm oil gets further processed depending on its final destination. Some gets fractionated into different components for specific applications. Some gets blended with other oils for particular cooking properties. For food manufacturers, refined palm oil is like a Swiss Army knife, incredibly versatile and reliable. It provides the smooth texture in chocolate that keeps it from melting in your pocket. It creates the flaky layers in pastries that make them light and crispy. It gives margarine the right consistency to spread easily while remaining stable. In your kitchen, palm oil performs tasks that would be difficult or impossible with other oils. Its high smoke point makes it perfect for high-temperature cooking without breaking down or producing harmful compounds. Its natural stability means foods fried in palm oil stay fresh longer than those cooked in less stable oils. What makes this entire process even more impressive is that it never stops. While one batch of fruits is being sterilized, another is being threshed, another is being pressed, and yet another is being refined. It's a continuous flow system where millions of fruits enter one end and golden oil emerges from the other in a never-ending cycle of transformation. The coordination required is incredible. Plantation managers schedule harvests to ensure steady fruit supply. Mill operators adjust processing rates based on fruit quality and quantity. Refinery technicians modify their procedures based on crude oil characteristics. Transportation crews maintain the flow between each stage. It's like conducting an orchestra where every musician is playing a different song, but somehow it all comes together perfectly. This entire system processes about 200,000 tons of palm fruits globally every single day. That's equivalent to processing the weight of about 1,300 blue whales daily, transforming all of it into the versatile oil that touches virtually every aspect of modern life. From those skilled workers climbing towering trees in tropical plantations to the sophisticated refineries producing crystal-clear oil, this process represents one of humanity's most efficient food transformation systems. Every day, millions of spiky orange fruits complete their journey from tropical trees to the golden liquid that quietly powers modern civilization. The next time you see cooking oil, chocolate, soap, or any of the countless products containing palm oil, remember this incredible transformation. Behind that simple product is a process that turns nature's oil storage system into liquid gold through a combination of traditional skills, modern engineering, and precise chemistry that happens millions of times over, every single day, around the world. What started as fruits hanging from tropical trees becomes the versatile foundation that makes countless products possible. It's the hidden transformation that connects distant plantations to your daily life, one golden drop at a time. If you found this journey from fruit to golden oil as fascinating as I did, smash that like button and hit subscribe to see more incredible processes that happen behind the scenes of everyday products. Trust me, once you start seeing how ordinary things are made, the world becomes a much more interesting place.